Good afternoon, class. We are looking at final exam review, which covers modules 1 through 4, trigonometric functions, identities, applications, periodic functions, polar coordinates, and vectors. Name the quadrant that this belongs to. T equals 2. Reminding everybody of a unit circle, x squared plus y squared equals 1. Sine represents the y, cosine represents the x, tangent is y over x. And you can see the rest of them that are the reciprocals, so that's good enough. So remember, this is located at 0, and this is pi over 2. Pi over 2 is about 3.14 divided by 2, so it's about 1.57. Pi is about 3.14, and 2 pi is about 6.28. And so when t is between 0 and 1.7, puts us in the first quadrant, between 1.57 and 3.14 in the second, between 3.14 and 4.71 in the third, and between 4.71 and 2 pi or 6.28, roughly. This is the rough approximation of pi. That gives us the fourth quadrant. Therefore, 2 belongs to this area. 2 belongs to this area, so it makes it the second quadrant. Okay. We want to find the exact answer for cosecant. We know that the reference arc is pi over 2. So we can take off multiples of 2 pi. 8 pi over 2 is the same as 2 pi, and that is the same as cosecant of 3 pi over 2. Cosecant is 1 over sine, which means 1 over sine of 3 pi over 2. As you know, 3 pi over 2, the sign is negative 1, so the result is negative 1. So it makes it very easy to follow. The length of an arc S is 50 inches in a circle with a radius of 6 inches. Find the angle theta that this arc subtends. Find the area of the sector formed by the central angle theta. And so what is given? S is 50, R is 6 inches. And so we want to find the theta. In this case, as you know, S equals R theta. S equals R theta. That means theta must be S over R, and that gives us 25/3 radians. The units are in paid radians always. And the area of the sector, this area, is 1/2 R squared theta, so plug in, simplify, and you get 150 inch squared. Find the linear velocity of an object on the rim of this circle if it is spinning at 40 RPM, revolutions per. This last one is the unit of time, RPM, RPS, and so forth. So it's per minute. And so R is 6 inches. Omega is for the RPM, we want the V. So first and foremost, omega, the angular velocity, is 2 pi times RPM or RPS with the proper units. So 2 pi times RPM, that means 2 pi times 40, resulting in 80 pi radians per minute. And V is R omega. V is R omega. So multiply the two. 6 times 80, 480 pi. This is the exact answer, 1,507.96 inches per minute. You always have to write down the units accordingly, everybody. We want to simplify, and reminding everyone of Pythagorean identity. Sine squared plus cosine squared is 1. 1 plus tan squared is secant squared. 1 plus cotangent squared is cosecant squared. So if you put these two together, you get 1 is 2, and 1 plus cotangent squared is cosecant squared. These 2 is 1. Cosine of power 6, secant of 13 pi over 6. So first and foremost, we are going to take out 12 pi over 6 minus 2 pi, which is 2 pi over 6, which is 12 pi over 6. And so secant is 1 over cosine. So you're dividing by cosine of pi over 6, and therefore the answer is 1. Cotangent of theta minus pi, cotangent of theta minus 2 pi, reminding everyone about the fact that all trigonometric functions are periodic with the period of 2 pi. Tangent has a period pi, so does cotangent. Therefore, this is cotangent theta. This is also cotangent theta because this is multiples of pi. Negative or positive makes no difference. Therefore, you have 3 of those. Find the amplitude, period, intercepts, and phase shift of this function and sketch it. And generally speaking, y equals a sine b times x minus c over b plus d. There are different ways of writing them. Okay, class. So that's really the bottom line. And so obviously the amplitude is absolute value of this number, which makes it 6. T equals 2 pi over omega or 2 pi over b, because sometimes they use omega to represent that. So 2 pi divided by pi over 3 results in 6. So remember what we're going to do. We're going to go with 4 parts, 4 arcs, and that's why we cut the period into 4 equal parts divided by 4, and you end up with 3 halves. Okay. And remember, there's no phase shift. So you start from 0, you go to 3 halves, and then you add 3 halves until you end up with 6. So 3 halves, 3, 3 9 halves, 9 halves, 6. Please understand what's happening here. The first one is 0 and 3 halves. If you add 3 halves to this, you get this one. Add 3 halves to this one, you get 9 halves. And finally, this one. If you don't get that, somehow we made a mistake. So we are going to plug in some easy numbers. For example, the endpoint's 0. If I put a 0 here, sine becomes sine of 0, which is 0, and the answer is positive 4. If I look at this one, in other words, this is positive 4. If I don't look at this, that takes this one and shifts it up by 4 units, this is 0, this is 4, everybody. So for this one, I'm going to put 4. It's easier to deal with this one. Just put 4. Put 0 here. If I put 1.5 divided by 3, okay, I get if I put this one 1.5, I get minus 6 sine of power 2. This is 1, so I get negative 6. And you can figure out the rest. If I put 3 here, cancels out this one, sine of pi is 0. So I get minus 6 times 0, which is 6, which is 0. And if I put 4.5, I end up with 6. If I put 6, I end up with 0. So I have those. And let me erase mine. So those are the pairs I'm going to graph. 0, 0. 3, 0, and 6, 0. Now, the max and mean, and that would be the graph. Again, this is for this one. But to go back to this one, we are going to shift it by 4 units. That means vertical shift of 4 units, 4 units up. So y equals 4. In other words, also known as a midline. Y equals 4 is called the midline. In other words, all of this, look at those numbers. Put the same numbers and add 4. So 0 plus 4. So I put 4 here. Minus 6 plus 4. I put negative 2. 0 plus 4. I put 4 here. 6 and 4. I put 10 here. 0 and 4. I put for you. That would be probably the fastest way to get those pairs. That's the answer, and you can go indefinitely on the left and right. However, there is one complete period, and that's good enough. What about this one? We're going to repeat the question here, everybody. And we want to sketch the graph of this function. So the very first thing we need to do is just to take the 3 out. So this becomes x. And therefore, you have to divide this one by 3 becomes power 6. That's the first thing. Take the 3 out. Therefore, what happens is that the amplitude is 2. The period is 2 pi divided by 3. And I have the information here, 2 pi divided by omega or b. Because we have a number sitting next to this, there is a phase shift x plus pi over 6, means the phase shift is negative pi over 6. We cut the period in 4 equal parts because we want to go with 4 arcs. And 2 pi divided by 3, that means 2 pi divided by 12 or pi divided by 6. So we are going to start from here because there's a phase shift starts from minus pi over 6. And then we start adding pi over 6. So minus pi over 6, you add pi over 6, you get 0. And you keep on going. So this is going to go from minus pi over 6 to 2 pi over 3 plus negative pi over 6. So the entire domain for one complete period goes from minus pi over 6 to pi over 2 because we are going to add minus pi over 6 to 2 pi over 3. So minus pi over 6 to 0, 0 to pi over 6, pi over 6 to pi over 3, pi over 3 to pi over 2. And the reason why is very simple. This is the start. We add pi over 6 and we get those numbers. Let's put the numbers in by looking at easy numbers. For example, all of these endpoints minus pi over 6. If I put it here, it might be easier to use this one. If I put minus pi over 6 here, it becomes 0. 3 times 0 is 0, and cosine becomes 1. This makes this one 2. If I put 0 here instead of x, I get 3 times pi over 6. 3 pi over 6 is pi over 2, cosine is 0. Therefore, I get 0 here. If I put pi over 6, and pi over 6 is pi over 3, times 3 is pi, cosine is negative 1, times 2 becomes negative 2, and you can figure out the rest of it. So let's plug in minus pi over 6, 2, 0, 0, pi over 6, negative 2, pi over 2, 0, pi over 3, 0, pi over 2, 2, and that's the graph. And if you want a couple more points, you can do that, class. And you can continue indefinitely on the left and right. Find the exact value, calculators. Tan inverse of tan, you have negative 2 pi over 3. So first reminding everybody that in the case of a sine, y equals sine and inverse of x means x equals sine y. And none of the trigonometric functions have an inverse unless we do the restriction. The restriction for sine we put was from negative pi over 2 to pi over 2, so we can get the range. So when x is between minus pi over 2 and pi over 2, sine inverse of sine is x, and sine of sine inverse is equal to x. The restriction we put on tan inverse is we put on tan was the same thing as sine, but the endpoints are not included. For cosine is from 0 to pi, the restriction we put in. And therefore, for cosine inverse cosine of x becomes x if x is between 0 and pi. If x is between negative 1 and 1, cosine of inverse equals x. And then cosecant follows the sine. Okay, of course, y can't be 0, and secant follows the cosine of y can't be power 2, and cotangent inverse actually also follows cosine in order to have all of them. And again, reminding everybody about various quadrants and which one is positive, which one is negative, and so forth. So tan of negative 2 pi over 3, as you can see quickly, pi over 3 is the reference arc. Negative 2 pi over 3 puts us in the uh, third quadrant. And so tan inverse of square root of 3, and that is pi over 3. Secant inverse of square root of 2. Let's say it's alpha. By definition, secant of alpha becomes square root of 2. Let's go to cosine. Cosine is 1 over square root of 2 or square root of 2 over 2, and therefore alpha becomes pi over 4. So to answer secant, we go to cosine. Cosine inverse of 1/2. Let's call it alpha, beta, gamma, theta. Cosine theta is 1/2, and theta is pi over 3. Tan of cosine inverse of square root of 3 over 2. So we start with this and we call it something, for example, beta. By definition, cosine of beta becomes square root of 3 over 2. It's a common arc, makes it pi over 6. We want tan of pi over 6. We know it to be square root of 3 over 3. Cosine of cosine inverse of 1.2, that's undefined. Why is that? Because 1.2 is larger than. So a quick recap. Um, First quadrant, everything is positive, sine, cosine, and the rest of it. Second quadrant, sine is positive, therefore is cosecant. In the third quadrant, everything is negative except tangent, and with tangent goes cotangent. That's why we got actually for this one, because it puts us in the third quadrant. In the fourth quadrant, everything is negative except cosine, and with cosine goes secant. Write trigonometric expression for this guy. And again, Pythagorean identities, the situation with tan inverse, various quadrants. And so we start saying, let tan inverse of u be something, which means tan theta must be u, and we are interested in sine theta. There are various ways of approaching it. For example, cotangent is 1 over u, because tangent is u. Sine is what? We can say 1 plus cotangent squared equals cosecant squared. We are using one of those Pythagorean identities, and cotangent is 1 over u, so this is 1 over u squared. And so if I take a common denominator, this is u squared over u squared, so we get u squared plus 1 over u squared. And if cosecant squared is this, then sine squared is the reciprocal of that. So sine is plus minus the square root of root. And we keep the positive only because sine and tan have the same sign. Remember, sine and tangent, both of them, for the inverse function, we restricted from minus power 2 to power 2. Another methodology, tangent, we go back to this one. Tangent is u because it doesn't have, it's not a fraction, it doesn't have a denominator, and we have opposite over adjacent. We make up the denominator as 1. This doesn't have to be to scale, but this is u, this is 1. So we can find this by 1 squared plus u squared under the radical, which makes it 1 and u squared. And now we want sine theta. So sine is the opposite, okay, which is u over the hypotenuse, which we just found. So that is using triangles. This is using identities, and I thought it's worth looking at both. Various formulas, sum and differences. For example, sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta, the rest. With that, we can get the double angle. Sine of 2 alpha becomes 2 sine alpha cosine alpha. And from here, we can find sine squared and then alpha over 2. From the green one, we can get cosine alpha, cosine squared, and tangent is the ratio of sine to cosine. So I'm in essence reminding you how to find all of these, okay? Even if you haven't memorized it, if you know just a few of them, you can come up with the rest of them. And those are half-angle formulas and the product to sum and sum to product. So just to remind you of the formulas. For example, we want to find sine of 195 degrees, and we can say using the half angle is 390 divided by 2. Remember, 390 is 360 plus 30, and it's a common arc. And therefore, that 390 degrees is 360 plus 30. That means the first quadrant. So we go with the formula that we have here, plus minus the square root of 1 minus cosine alpha over 2. So it makes it 390 degrees. And as I mentioned, 390 is the same as 30 degrees. So this is the same as 30 degrees. Now we're going to decide about the plus minus. 390 divided 195 or 390 divided by 2. This is more than 180 degrees. It's in quadrant 3. In quadrant 3, sign is negative. That's why we end up with this sign here. You put cosine of 30 as square root of 3 over 2. You multiply the top and the bottom by 2 by 2. And you get the square root of 2 minus square root of 3 under the radical over 2. Cosine of 15 degrees is 30 over 2. And we're going to use the cosine formula for that. By the way, plus minus, but this 15 degrees is in the first quadrant, so we use the plus only. And again, we multiply the top and the bottom by 2. And there you have it. You can try cosine of 15 is cosine of 45 minus 30. Cosine of power 2 plus x equals minus sine x. We're going to prove that, and we are going to use the identities, okay? In this case, cosine of alpha plus beta. Cosine alpha cosine beta minus sine alpha sine beta. Therefore, cosine power 2 cosine x minus sine power 2 sine x. As you know, cosine of power 2 is 0, sine is 1. This cancels out to 0. This goes to 0, and this becomes minus sine x. What about this one? Again, we start from one side, left-hand side, and tangent over secant becomes sine over cosine over 1 over cosine. And if you multiply the top and the bottom by cosine, I hope you realize the cosine goes away and you get sine theta over 1, which is sine. Just 2 sine power 8 cosine power 8, reminding everybody that sine of 2 alpha is 2 sine alpha cosine alpha. So therefore, this is sine of 2 alpha. That means sine of 2 times power 8, which is power 4. And as you know, sine of power 4 is square root of 2 over 2. 2 sine 45 cosine 45, sine of 2 times 45, sine of 90, which is 1. Cosine of 7 pi over 12, it's the sum of 3 pi over 12, which is pi over 4, and 4 pi over 12, which is pi over 3. And both of them are common arcs. So cosine alpha cosine beta minus sine alpha sine beta. Cosine of pi over 4 cosine of pi over 3 minus sine of pi over 4 sine of pi over 3. Common arcs, this is square root of 2 over 2, this is 1/2. This is again the same thing, square root of 2 over 2, this is square root of 3 over 2, and both of them have the denominator 4, this is square root of 2, this is minus square root of 6. Don't forget this. You recognize this again as one of those. This is cosine alpha cosine beta plus sine alpha sine beta. That makes it cosine of alpha minus beta. So cosine of power 2 minus 5 power 2, which is cosine of minus 4 power 12. As you know, cosine is an even function. So cosine of minus theta and cosine of theta is the same thing. And 4 power 12 is power 3. Cosine of power 3 is 1/2. We are done. Cosine of 105 is 105 is the sum of 60 and 45 degrees. So cosine alpha cosine beta minus sine alpha sine beta. Cosine of 60 is 1/2. 45 cosine is square root of 2 over 2. This one is square root of 3 over 2. This is square root of 2 over 2. Both of them have the same denominator 4, square root of 2 minus square root of 6. Very straightforward, reminding you of things we have done. Tan of theta plus cosine over 1 plus sine is secant theta. We start with the left-hand side, the more complicated side, and we change everything to sine and cosine. So tan theta becomes sine over cosine. Now you take a common denominator, which is the product of these two. And so this becomes sine times 1 plus sine theta. So you multiply these two, you get sine theta plus sine squared. You multiply these two, you get cosine squared. So I'm simply taking the common denominator. Sine squared and cosine squared adds up to 1. Therefore, we can drop this with this, and we get 1 over cosine, which is secant theta. And that's the proof. What about this one? Again, we start with the left-hand side, and we take a common denominator. That means we're going to multiply this one by this one, minus multiply this one by this one, and the denominator is sine theta cosine theta. Take a common denominator. So I hope you recognize this as sine alpha cosine beta minus cosine alpha sine beta, okay, which is sine of alpha minus beta, or sine of 3 theta minus sine of theta, and this is half of that, so it's half of 2 sine theta cosine theta. Right, so this is sine of 2 theta, this is sine of 2 theta, and these two cancel each other. We get 1 over 1/2, which is 2. We want to solve the equation, and we have cosine squared as well as sine squared. Because this is sine, we're going to change this one to 1 minus sine squared. And so we have 1 minus 2 sine squared plus sine x. Because we want this to be in descending order, we take everything to the other side. And now it's a simple case of a factoring, because 2 is a prime number. -1 is simply 1 and -1. And so either sine x is, so 2 sine x plus 1 equal to 0 sine, or sine x minus 1 equal to 0. This gives us -1/2. This gives us 1. So remember, think about 1/2, which gives you pi over 6, and sine is negative in the third and fourth quadrant. That gives us 7 pi over 6 and 11 pi over 6, and sine x equals 1 only pi over 2. When we solve this one, it is in the format we wanted. We just factor it. This one is 0, or the second one. This results in cosine theta being negative 1/2. This one cosine theta being positive 1/2. If you think of 1/2, it makes pi over 3 the reference arc. Okay, negative puts us in the second as well as the third quadrant, 2 power 3 and 4 power 3. And of course, cosine theta is 1 when theta is 0. Those are the answers. We want to find this one. First, sine x equals 1/2. The answers are pi over 6 and pi over 6. However, x is 3 theta. The methodology for multiple angles is as follows. You said 3 theta equals pi over 6. And you would write 3 theta is pi over 6 plus 2n pi. Divide by 3. That means multiply this one by 3. And this one is that. And of course, the answers could be the same thing for 5 pi over 6. You're going to add 2n pi and divide by 3. This becomes 18. This becomes divided by 3. And then you have to put all the numbers from 0, 1, 2 to n minus 1, because this is 3. You end up with 2. So you plug in here 0, 1, 2. 0 gives you pi over 18. 1 gives you 13 pi over 18. 2 gives you 25 pi over 18. You do the same thing here. 0, 1, 2. And that gives you 5 pi over 18, 17 pi over 18, 29 pi over 18. In short, this one from 0 to 2 pi, when it's a single angle, has 2 answers. If it's 3 times that, it has 3 times 2, 6 answers. If it's 4 theta, it has 4 times 2, 8. And to get all of those, in this case 6, this is the methodology. Solve the right angle. A, B, C are given as follows. And so you plug in what is given, what is missing. And so a squared plus b squared equals c squared. You put it in, and this is 64. This is 4. They add up to 68. And the square root of 68, or 4 times 17 is 2 square root of 17. This is a rough estimate. Now that you have all sides, you can use, for example, tangent. Tan of this is the opposite, 2 over the adjacent 8, or 1/4. B is tan inverse of 1/4, 14.03 degrees. You subtract this from 90 and it gives you the last one. And you have all the angles. So this is using the right triangle. It's very simple. A balloon is flying at a height of 600 feet. Directive of the Statue of Liberty, what is the angle of depression from the balloon to some airport that is 5 miles from the Statue of Liberty? Draw a diagram. It can't be, in my opinion, it can't be done without a diagram. And of course, remembering that 1 mile is 50 to 80. So here's the definition. So you're standing here, you're looking up, and it makes an angle with the horizontal plane. That is the angle of elevation. Looking down is angle of depression. Angle of elevation is the angle formed by the line of sight, and the horizontal plane for an object above the horizontal angle of depression is the angle formed by the line of sight and the horizontal plane and object below the horizontal. So in this case, here's the balloon, and this is 600 feet. Here's the airport. Here's 5 miles, and here's the angle that is theta, and that is also the same as this angle. So tan of this theta is the opposite over the adjacent. So alternate interior angles are equal. So 600 feet over 5 miles. Either you change this or you change this to have the same units. It's easier to change this to 5 times 50 to 80. You must use the same units. The units must cancel each other. And now tan theta is tan inverse of this number, putting it into a calculator, and however many decimals, that would be the answer accordingly, 1.302 degrees. So it's very simple to find that. An aircraft is spotted by 2 observers who are 1,000 feet apart. This is 1,000 feet. As the airport passes over the line joining them, each observer takes a siding of angle of elevation to the plane, 40 degrees and 35 degrees. How high is the plane? So let's see what's going on here. First and foremost, we call this side y, this height which we are looking for h. And so the angle P or Q, this must be 105. Why is that? 40 plus 35, 75. Subtracted from 180 gives us this angle. Okay. Now, in order to find h, we need y. And so we go with the sine law, sine A over A equals sine B over B equals sine C over C. So we can recognize these two angles, by the way, at 50 and 55, because 35 plus what number is 90 degrees? 40 plus what number is 90 degrees? So it's easy to figure out those numbers. So sine of 105, this is 105, divided by 1,000 is sine of 35 divided by y. So cross product gives us the y, or PR. Sine of a 40 is the opposite h over y. And h is the product of these two numbers. Sine of 40 times that using a calculator, we will get this number, 381.69 feet. This was the question. This is what we were looking for. How high is the plane? Two boats that are leaving the harbor in different directions make an angle of 135 degrees. One boat has traveled 300 feet and the second one 350 feet. How far are these boats apart? So here's the drawing, here's the setting. I can't emphasize this enough. You have to have that. And so the bottom line is this distance is 300 feet. Distance is 350. They make an angle of 135 degrees. The question is, what is this? And now you can use the cosine law. A squared is b squared plus c squared minus 2bc cosine. So when do you use the cosine law? When you have two sides and the included angle, the angle in between. So a squared is 300 squared plus 350 squared minus 2 times the product of the two times cosine of 135. You put it into a calculator, gives you a squared, take a root, and gives you a 600.83, about 601 feet, roughly. A rocket takes off at a bearing of north 30 degrees east. After flying for 900 meters, the pilot turns 90 degrees and heads northwest. After flying for 1,000 meters, what is the new bearing of the plane? Reminding everybody, when we have the bearing, basically you have two methods. The method that is mentioned here is you compare it with the north or south, and the angle must be between 0 and 90 degrees, an acute angle. So for example, this one is north, 30 degrees east. Okay, this one is still north, but this time 70 degrees west. This one is south now. South, 50 degrees west. What would this one be? South, 20 degrees to the right, east. Okay, so that's the concept. Now, north 30 degrees east means going this way. Okay, after flying 900 meters. So first we go 900 meters. Then we make it 90-degree angles, either this way or that way. That is a 90-degree angle. So drop a perpendicular. Which way? We're going to go with northwest. So we go this way. You can go even down for 90 degrees, but and that way we go 1,000 meters. What is the new bearing? So we do the drawing, and the bearing is clearly going north. This side is west. We need this angle. In other words, if this is alpha, north alpha west. So what do we do? It's very simple. We find this angle. We know this is 30 degrees. So alpha is this blue angle, theta minus 30 degrees. So theta minus 30 degrees. So all we have to find theta. And it's easy to find. This is 900, this is 1000. So tan of theta is the opposite 1000 over the adjacent 900. Put it into a calculator and you come up with the angle 48.01 degrees. Subtract 30 degrees and that's alpha. And so north 18.01 degrees west. That's how you get it. Plot the points first, then find their coordinates. And in this case, we have 6, 150 degrees. We want to find the rectangular coordinates. So 150 degrees. And you go how many? 6 tick marks. Okay. So that means 1 and 2 and 3 and 4 and 5 and 6 circles. That's it. Now, as you know, x equals r cosine theta, y equals r sine theta. Okay. And so we plug in 5 pi over 6, the same as pi over 6. Cosine is negative in the second quadrant. So square root of 3 over 2 becomes negative, and the answer is minus 3 square root of 3. Y equals r sine theta, and sine of pi over 6 is also the same as sine of pi over 6, but this time positive because sine is positive in the second quadrant. The answer is 3. So this point has coordinates 6, 150 degrees or minus 3 square root of 3 in rectangular coordinate system. What about 2 and negative 2? Go 2 to the right, 2 down. And rectangular x squared plus y squared equals r squared. Tan theta is y over x. It's just for the quadrant. So in this case, 2 squared and negative 2 squared, they add up to 8. R becomes 2 squared of 2. Tan of theta is y over x, which is negative 1, makes it negative pi over 4. And so you can answer it this way. If you want to go with the positive, so this is negative pi over 4. Positive, all you have to do, add 2 pi or 8 pi over 4, and that gives you 7 pi over 4. So that's the correct answer as well. Transform the polar equation to an equation rectangular form. Well, x equals r cosine theta, r squared equals x squared plus y squared, r equals 2 cosine theta given. The technique is to multiply by r. We get r squared equals 2r cosine theta. And this is x squared plus y squared. This is 2x. We bring the 2x next to x squared. And now b is negative 2. Divided by 2, negative 1, squared is 1. Added to both sides becomes x minus 1 quantity squared plus y squared equals 1. And as you recall, circle centered at 0, 0, x squared plus y squared equals r squared. At a different center, x minus h quantity squared plus y minus k quantity squared is equal to that. Therefore, it's centered at 1, 0 with the radius 1. So we're going to use 2 tick marks because it's small as 1. So 1, 0, and then pick up the circle. Identify the graph. R equals 4. If we square both sides, r squared becomes 16. X squared plus y squared equals 16, which is a circle centered at the pole with the radius 4. Theta equals 3 pi over 4. If you take a tangent on both sides, tan of theta is tan of 3 pi over 4, which is negative 1, and that's y over x. Cross product, y equals minus x. As you know, y equals x is this line, y equals minus x is this line. It's a line through the origin. Reminding you that R is A, it's a circle centered at the pole with the radius A. Theta equals alpha is a line, y equals tan alpha times x. If you have r sine theta equals a, y equals a, it's a horizontal line. If you have r cosine theta equals a, x equals a, it's a vertical line. And all of this, r equals plus minus 2a cosine theta or plus minus 2a sine theta, those are circles with the radius a, with various locations as far as the center is concerned. To graph this, we're going to quickly graph this by plotting points. Okay, and it represents a cardioid. Theta is given, or 1 minus cosine theta. And just as an example, if I plug in 0 class, I get 1, 1 minus 1 is 0. If I could put power 6, I get square root of 3 over 2, so 1 minus that, and the rest of it. And those are the pairs. So if we plot easy ones, 0, 0, and again, we're going to go with 2 tick marks being 1, and then 1/2 power 2. You look at power 2 and you go 1/2. 1 power 2, you look at power 2 is easy, is the y-axis, the positive side. And pi is this way, and 2, remember 2 tick marks is 1, so you go 4. Okay, and it looks like that. Symmetry, we notice that if we replace the theta with minus theta, nothing changes. And if that is the case, it is symmetric with respect to the polar axis. So you can see the graph. You can use more points. I don't worry about that. This is the graph going and using the symmetry, if you will. I'm going to plot the complex number in the complex plane, reminding everybody of z being x plus y or a plus bi. These are cis theta. R squared is x squared plus y squared, and tan theta is y over x. And basically, you have the x-axis as the real line or real axis, and the y-axis as the imaginary. And so in this case, 1 and I, again, we're going to go with 2 tick marks to represent the 1, and it makes it easier that way. And this is 1 comma 1. And R is square root of x squared plus y squared, resulting in square root of 2. Tan theta is y over x, and it becomes 1. Theta is 45 degrees. Z is 1 plus I, or R cis theta. So square root of 2 cosine 45 plus R sine 45. We want to write the complex number, okay, in rectangular form and plot that. So first and foremost, 7 power 4. Remember, the reference arc is power 4. It's the same as power 4. Cosine is positive in the fourth quadrant, and sine is negative. Both of them are square root of 2 over 2. This is positive square root of 2 over 2. This is negative. Drop the 2 and change this to 2. So 2 square root of 2 minus 2 square root of 2i. So the theta is 7 power 4. And we are going to go with this. So 2 square root of 2 is about 1.4. So 2 times that is 2.8. So about 2.8 on the right, 2.8 the bottom, and there you have ZW and Z over W. You want to find those where Z is given and W is given. Reminding everybody that when we have R cis theta Z1, Z2 is R1, R2 cis theta 1 plus theta 2. So we want to multiply these two, which means we're going to multiply their modulus or magnitude 2 times 2, and then we're going to add their arguments. So 2 times 2 cosine of power 8 plus pi over 10, and I sine of power 8 plus power 10. So simply put, we add these two. As you can see, the common denominator is 40. 4 divided by 8 is 5. 4 divided by 10 is 4. And that's why we get 9 power 40. For dividing them, we divide these two numbers, and then we subtract these two according to this. So power 8 minus power 10, and because this is 5 power 40, this is 4 power 40, the difference is power 40. What about this one, raising it to the power of 6? We use De Moivre's theorem. According to De Moivre's theorem, if you want to raise this to the power of 6, and then multiply the argument by n. So this means 3 cubed, and this means 6 goes away, 18 becomes 3. So 5 power 3 is the same as power 3 for the reference arc. Cosine is positive, sine is negative. 3 cubed is 27. So 27 times 1/2 minus square root of 3 over 2 times I, and this is what we get. 27 halves minus 27 square root of 3 over 2 times I. Given z equals 8, find the complex cube root. Okay, and first and foremost, it's 8 cis 0. I'm reminding you that a positive number such as 8 is 8 cis 0. Negative number is 8 cis pi, okay? And then we are going to use this. So we are going to add 2k pi times, and if whether we want, degrees, okay, this is divided by n, or not, it's up, whatever makes it easy is good enough. And so in this case, 0 over 3, so this goes to 0, and this one remains, and square root of cube root of 8 is 2. So all you have to do, replace this with 0, 1, 2. As you know, this becomes 2. You can work it out. 2 cosine 0 and sine 0. This is 0, this is 1, and we get 2. If you plug in 2 pi over 3, you end up with negative 1 plus I squared of 3. And if you put 4 pi over 3, you get negative 1 minus I squared of 3. Vector has initial point P and terminal point Q, write in the form of AI plus BJ, find its position vector, and so forth. Well, by definition, okay, if you have a vector and if you move it such that the initial point is at the origin, it's called the position vector, okay? So position vector, AI plus BJ, okay? A and B are called components of the vector. So if you happen to have those coordinates, then you write x sub 2 minus x sub 1, y sub 2 minus y sub 1. So in this case, you are going to write 5 minus 3, 6 minus 2. And obviously you get 2 and 4. Or you can write it as 5 minus 3i plus 6 minus 2j, and you get 2i plus 4j. It makes no difference. The magnitude is square root of a squared plus b squared. So that means 2 squared plus 4 squared. And that is 4 and 16, 20. And 20 is 4 times 5, so 2 squared of. Given v and w, find the magnitude of v and then the rest of them. The magnitude, square root of a squared plus b squared. So we have minus 2 squared and 3 squared under the radical. 4, 9, they add up to 13. V plus w, just add them up. And all you have to do, add up the components. And they give us 3i. These two give us minus j. 2v minus 3w. Let's put the 2 in front of v, minus 3 in front of w. And we get minus 4i plus 6j minus 15i plus 12j. And again, these two minus 19i, these two plus 18j. So it's very straightforward, everybody. Find the magnitude, direction, angle, and a unit vector in the same direction for this vector. First, let's get the magnitude, square root of a squared plus b squared. 3 squared and 3 squared, 9 and 9 is 18. By now, you know it's 9 times 200, 3 squared root of 2. Direction angle, tan of alpha is b over a, 3 over 3, which makes it 1, and it's in the first quadrant, of course, right? So that makes it 45 degrees or power 4. So What is the vector? All you have to do, write it with that format. You can write it, the magnitude that we have, times cosine alpha I plus sine alpha j. So that's in that format. We want the unit vector in the same direction. All you have to do, divide this one or this one, doesn't matter, it depends on how you want it, by its magnitude. So unit vector is the vector divided by its magnitude. So we're going to divide this by its magnitude. So we have the vector and the magnitude is this. So we can get rid of the 3. And we get 1 over square root of 1 over square root of 2 is the same as square root of 2 over 2. A plane is flying at a speed of 200 miles per hour. On a bearing of north 55 degrees east, the wind is blowing from west to east at 35 miles per hour. Approximate the ground speed of the plane to the nearest mile per hour and the true course of the plane to the nearest tenth of a degree. Well, north 55 degrees east, which gives us this angle of 35 degrees. And so the magnitude is 200 miles per hour. And the this is with respect to the 90 minus 55 or 35 degrees, the angle with the positive side of the x-axis. The wind is going this way. The magnitude is 35. It's parallel to the x-axis. The angle is 0 in the positive. It's going in this positive side. And so they add up and they give us this. So we need to calculate the magnitude. And as far as the true course is concerned, if this is theta, this is what we need. And so the magnitude, after we find the north, 90 minus theta east, that would be the true course. So let's add up. If we want to add them up, we are going to write them as components, 200 cosine of 35i plus sine of 35j, and you use a calculator. This one, we do the same thing. As you know, cosine is 1, sine is 0. I don't need a calculator. So cosine is 1, sine is 0. So it's just positive 35i. And when we add them up, we just add up these two components because they are I components. So what is the magnitude? Square root of a squared plus b squared, which means square this number under the radical. And it gives us about 230 miles per hour. What about theta? We can find it as b over a. So this number over this number. Put it into a calculator, you get 30 degrees. And what do we want here for the true course? 90 minus 30, that means 60 degrees. So it's doing 230 miles per hour, north 60 degrees east.